Okay, when we're talking about differential equations, we have something that generally looks like this, right? This is the derivative notation, dy dx, and here we have some type of a function, right, or a curve in terms of y and x. Okay, so what we're going to do is we're going to get all of the y stuff on the left side and get all of the x stuff on the right side, right? This is called separation of variables. Oh, like it says right here, separation of variables. So we're going to cross multiply. We're going to take this y and multiply it over to the other side. And then we're going to take this dx and multiply it over there. Okay, so our equation will look like y times dy equals 2x dx. Right, so multiplication between these things right there. We want to solve this equation for y as a function of x. Okay, so hopefully you know, how do we get rid of the dy's and the dx's? Well, we do that by integrating. So we're going to take the integrals of both sides. Okay, which is why we do differential equations after we study integrals. So on the left side, what is the antiderivative of y? Y squared over 2. Fantastic. And on the right side, what is the antiderivative of 2x? That's just x squared, right? So it would be 2x squared divided by 2, right? We use the power rule. We add 1 to the power. We divide by 2. So 2 divided by 2 is 1, right? Because think about it. What is the derivative of x squared? 2x. So it's the antiderivative of 2x, x squared. Okay, now there's always this plus c anytime that we do a integral. Okay, so now let's solve this for y. Our first step would be to multiply everything by 2. Okay, right, because we want to get rid of that denominator. So y squared equals 2x squareds. Now, you might not like this, but 2 times c is just some other type of c value. Okay, so we're never going to change our c to be any type of addition or subtraction or whatever. It's just going to stay c no matter what type of an operation we do to it. Okay, so our last step would be to square root both sides. So y would be equal to the square root of 2x squared plus, once again, some other value of c. Okay? We'll talk about the value of c here in a minute when we have something called an initial condition. Here we go. This is called a general solution. Okay, but what if we had an initial condition? We knew that y of -1 was -3. We're going to plug in 1 for x, right? This is your x value. And we're going to plug in -3 for y. Okay, so the particular solution happens when we replace our x and our y value with their, what we call an initial condition. And that allows us to solve this equation for c. Okay, once we solve it for c, that's going to be our particular solution. And in this case, c is not something that's very pretty, is it? It's root 3, or rather through -3 minus root 2. So our particular solution would be y equals the square root of 2x squared minus 3 minus root 2. And that would be your final answer. Okay, let's see if we can do another one. Solve for y as a function of x. So we have y prime equals x squared root y, and we have the initial condition that when x is 3, y is positive 4. Okay? So first let's replace y prime with its equivalent, dy over dx. Okay, so y prime is the same as dy dx. And now we're going to do separation of variables. So we bring our dx to this side by multiplying. And how do we get rid of root y? We divide. So we're going to divide both sides by root y. So we're only going to do separation of variables with multiplication. Right? We can only do it with multiplication or division. We cannot do separation of variables with addition or subtraction. Only with multiplication and division. So we have dy divided by root y equals x squared dx. And now we have the perfect setup to take the integral. So we're going to integrate both sides with respect to their variables. So we take the integral over here and the integral over there. Okay, so what are we going to do with this root y business? We're going to move it to the power as y to the negative 1/2 power. Okay, so we're always going to change our roots to be powers, because we have a power rule for antiderivatives, but we don't have a root rule for antiderivatives. So what is the y to the minus 1/2 antiderivative? Okay, we're going to use our standard rule and add 1. So we add 1, negative 1/2 plus 1 is positive 1/2. And then we multiply by the reciprocal. The reciprocal of 1/2 is 2. So the left side of our equation becomes 2y to the 1/2. Or 2 times the square root of y. Okay, that might look more like what we're used to seeing. Okay, so the 2 is your multiplier, y to the 1/2 is the square root. Okay, any questions about that? That seems okay? Now, what is the antiderivative of x squared? X cubed over 3. And then we have our plus c. So rather than solving this for y, let's go ahead and replace our x's and our y's right now. So we're going to replace x with 3, and we're going to replace y with 4. Okay, now is a pretty good time to do that, rather than having to solve this for y, because there's a lot of algebra involved in solving this for y. So let's wait as long as we can for that to figure out what our c value is going to be. Okay, so what is the square root of 4? That's 2, and 2 times 2 is 4. Okay, 3 cubed is 27. 27 divided by 3 is 9. Okay, so notice when we plug in early, we get a pretty simple calculations that we don't have to worry too much about. So now we know what our c value is. Let's go ahead and rewrite this with c. So 2 times the square root of y equals x cubed over 3 minus 5. Okay? So now it's a matter of solving for y. And AP doesn't need you to simplify at all. Okay? So as I do this, it's going to be ugly looking, but it is mathematically correct. And AP don't care. So don't make mistakes in simplifying. Just leave it as it is. So our first step to simplify would be divide by 2. So I'm going to divide this whole entire thing by 2. Yes, we could divide x cubed over 3 by 2 and get x cubed over 6. We could divide 5 by 2 and get minus 5 halves. That is perfectly acceptable, but so is this. Okay, once again, on a free response AP question, AP doesn't care if you simplify or not. Right, you could even, if you wanted to, write 1/2 and put all that in parentheses. Right, it doesn't matter. All of those things are mathematically correct. Okay, and our last step is to square. So we put parentheses around everything and we raise it to the squared power. And we can be done right there. AP doesn't need you to simplify this on an FRQ. Okay, now if it were a multiple choice question, yes, you would have to see what is the best equivalent to this whole entire thing as one of your 5 options. Okay, let's try another one. It's on the back of the worksheet, which is over here. Here's the back. Okay, dy dx equals 4xy squared. Okay. Now, the rule of thumb is if we have a constant, to keep the constant with x. Okay, so don't divide by 4y squared, just divide by y squared. So y squared is going to come over here as a division, right? It's going to be in the denominator, and dx is going to come over here. Okay, so we're going to have dy over y squared equals 4x dx. Okay, we're going to simplify our y squared in the denominator to be y to the negative 2 power. Okay, so we're going to simplify and make it look like that before we take the integral of both sides. So let's apply our rule. Y to the negative 2, we're going to add 1 to the power and get y to the negative 1 times by negative 1 equals the antiderivative of 4x squared is, 4x is 2x squared. Right? Because what happens if we took the derivative of 2x squared? We would get 4x. Right? So it's 4x squared divided by 2. 4 divided by 2 is 2. So we have negative 1 over y, right, that's the left side, equals 2x squared plus c. Anything to the negative power becomes a positive in the denominator. So this is a 1 over y as our simplified. So now let's plug in our values. We have an initial condition of x is 1 and y is 3. So let's plug those in there. Negative 1 over 3 equals 2 times 1 squared plus c. So when we subtract 2 from both sides, we get c is negative 2 and 1/3. And you can write it like that, or you can write it as negative 7/3 if you want. Probably negative 2.333, right, might be okay, but you'd never see that as an option on a test. So our final whoa, we're not done with our final equation, are we? Okay, let's come back up here and do some substitution. We're going to come back to this equation and replace c. Okay, we'll replace c right there. So negative 1 over y equals 2x squared minus 3 and 1/3. Or is it 2 and 1? It's 2 and 1/3. Silly me. It's 2 and 1/3. Okay, so how do we deal with this? Well, the y, how do we get rid of y in a denominator? We have to multiply both sides by y. So all of this gets multiplied by y. But then we want to get y by itself. So what do we do with all of this? We divide. We divide by all of that. So it's the negative 1 over 2x squared minus 2 1/3 equals y, right? No, it's not attractive, but mathematically it is correct. Okay, so before we go too far else, let's talk about proportions, right? Direct proportional is multiplication, and there's always this constant of proportionality. So y equals k times t if y is directly proportional, right? So here's an example. The amount of money I earn is directly proportional to the amount of hours that I work. Okay, inversely proportional means division. So y equals k divided by t, right? Your constant divided by. Inversely means divided by. As one goes up, the other goes down. Right? I think one of the gas laws in physics, gas of Boyle's law, as pressure increases, density decreases or something, one of those things. Joint proportionality is multiple products. So k times x times 5 minus x, right? Joint means multiple things going on at the same time. Okay, so those are the words. You're going to read these words. Population increases at a rate proportional to time. So population is k times t, right? A lot of these type of equations are going to be exponential and logistical growth equations. You're going to have to make them yourself with these words proportional. The population P increases at a rate proportional to its square root of the population. So that would mean the square root of P, right? Great growth. P prime, right? Increases at a rate, so rates. P is increasing at a rate proportional, right? These are derivatives. We find the function by taking its antiderivative or integral, right? Rate. The number of bears in a population is increasing at a rate directly proportional to 800 minus the population, right? So P of t, P prime, the rate is k, some proportionality constant, times this function, right? The rate. P prime is increasing at a rate directly proportional. So that's a multiplication problem. A certain population increases inversely proportional. So that is a derivative over 250 minus y. A lot of these problems don't come with equations, but they come with words like proportional or inversely proportional. And you're going to have to create an equation that we are then going to antiderive and simplify. Okay? So there you go. There's a quick differential equations, separation of variables. Use your initial condition to solve for C, and then solve that equation for Y. That is all. Goodbye.